Our goal in this problem is to classify the triangle by sides. In order to do that, we're going to first find the location for points M, N, and P, and then we're going to use the distance formula to find the lengths from N to N, then N to P, then P to M. Point N is the point 3, 3. Point P is 5, -1. And the coordinates for point M are -4, -1. We're going to use these 3 points in order to classify the triangle. Here's the distance formula. Let's find the distance from N to N. The difference between the x coordinates would be -4 minus 3 quantity square plus -1 minus 3 quantity square. This gives us 49 plus 16 under the radical, which equals square root of 65. Next, let's find the distance from N to P. Okay, the difference in the x coordinates would be 3 minus 5 plus the distance in the y coordinates would be 3 minus a -1, and square that quantity. This will yield 4 plus 16, which is square root of 20, and it simplifies to 2 radical 5. So far we can see that these two are not the same distance. Next and last, the distance from M to P. That's going to be the square root of the difference in the x coordinates, -4 minus 5 quantity squared, plus the difference in the y coordinates, -1 minus a -1 quantity square. That yields 81 plus 0 square, which is 0, and that's square root of 81, which is 9. We can see that all 3 sides are different lengths. Therefore, we say that triangle MNP is a scaling triangle. Note that we showed our work and proved the reason why it is a scaling triangle. We didn't just write the word scaling. Please show all work. Now it's your turn to try these problems. Graph the following triangles and then classify them by sides following the example that you just saw. Please note that it is not necessary to actually graph the triangles for you to find the length of the sides. You can just use the distance formula and give the answer. However, I would like for you to begin by graphing the triangles in this case.